How often do you try to understand a class or a code base you did not write? Let me guess, probably every day. I mean, as a developer, we often try to make sense of the APIs we use by accessing its code. And then there are other classes which might not follow a lot of standards, like legacy code, and they are a pain to understand. Wait, we have solutions like reading source code or documentation, navigating the call graphs, or setting breakpoints. But do they always work? And what about the legacy code that doesn't include comments? And what are the missing pieces? Is there even an exhaustive list to find out or the answers to all these questions? Because they are a lot of questions. Good questions, but I don't know the answers to all of them. But our speaker today definitely does. Hi, everyone. Thanks for joining in for another IntelliJ Idea Live stream. I'm your host, Mala Gupta. And now let me add our speaker, Raghunath Jawahar, to the stream. Raghunath, where are you?
Hey,
Hi,
Ma.
Raghunath.
Thank you for having.
Uh, First of all, let me welcome you properly. Thank you so much for accepting our invitation to present today. I'm so looking forward to learning from you.
Likewise, Mala. I am excited for the stream as well.
And to continue with the introduction, Raghunath is a consultant and an expert in working with the legacy code. And he helps organizations and team gain the testing and refactoring skills necessary for dealing with a lot of legacy code through pair programming and mentoring. And when he's not at his desk working with large files, he enjoys to travel, read books, run, play board games, and have a lot of coffee. And Raghunath, we already have a lot of comments and questions about people waiting about knowing how to make sense of large classes, especially working with legacy code. So we will have a lot of questions for you during the session.
Wow. That's really great. Thank you for the introduction, Mala. Uh,
And just a minute before I let you take the stage, let me quickly share a couple of housekeeping details with the audience. Everyone who's watching, please use the YouTube chat to post your questions. We'll try to answer your questions as you post them. Also, Raghunath will take breaks to answer your questions, so you don't really have to wait towards the end to ask your questions. And this session is being recorded and will be hosted on IntelliJ Ideas YouTube channel. So if you haven't already subscribed to our channel, now is the time to do that. And if you will like today's session, which I'm sure you will, please like the video and subscribe to the channel so that you don't miss similar content. And one last point before I let Raghunath take the floor. Everyone who's watching, I've been reading the comments and I know that you all are excited to learn more about this topic. It would be great if you let us know in the comments your favorite or go-to tools or techniques that you use to understand an unfamiliar class or code base. And we'll talk about it more when I ask questions to Raghunath. So thank you so much, Raghunath. I'll let you take the floor now and have fun.
Thank you for the introduction, Mala. I'm also excited. Hey, I know like a lot of folks are watching this from different parts of the world. I'm quite excited to be here, and this is also one of my favorite topics. It's one of my favorite topics because this is something that all of us as a developer in the developer community, we deal with this problem, but then we don't really actively discuss about this problem in the first place, right? And Mala has also mentioned that you've asked like a lot of questions, and I'm also excited to look into those questions. I may not have the answers for all, but then I think we'll learn a thing or two together. So today, this is going to be a 90-minute session. I know it's like an intense session, and it's going to be like a lot of stuff for you. But one is like I'll try not to overwhelm people with like a lot of details. I'll give you just bare enough information so that you can sort of like do this on your own and then research about it, learn about it, and even reach out to me on Twitter or social media to ask about these questions. But this is how we have structured this talk today. The first thing is we're going to talk about like some of the fundamental ideas. Like think about like few things that we not normally don't think about. And then the second thing is I'm going to show you a tooling demo on how you could actually approach this problem systematically and consistently across different code bases. And last thing is I also want to show you how do you deal with these kind of problems, right? So we will probably take one code base, which is a real world code base, and then look for one specific problem and then try to refactor it using IntelliJ today, right? So those are the three things. I don't want to get hung up on the fundamentals, like we'll make it through as quickly as possible, but we will go with the tooling demo and then the refactoring demo. I think like you folks are also excited as me for the demos. To get started, the first thing that I want to talk about is like the 80-20 rule, right? So fundamentally, it's the Pareto principle, and all of us know 80% of the outcomes come from the 20% of the effort, right? And that is not very different to your code base as well, because 80% of value that you're delivering to your customers through your software is probably coming from 20% of the code base, right? And this is like not a hypothetical situation. You could actually measure this by looking into your code base and then mining data from your version control systems to say, yeah, like 80% of your value comes from 20% of your code base. Like that based on the data that you see how your team is investing in building the software itself, right? Why large classes, right? So we have a lot of things to talk about, but then why did I pick dealing with large classes in general? So one of the things that I've noticed is over the past few years, when you start working with code bases, especially in code bases that have evolved very quickly or teams that have grown very quickly, most of the things that are important to the business gets put in one single place, right? And it looks like a dumping ground, and there is like a lot of problems here because the product teams or like the product owners always want you to uh, constantly keep delivering features to your customers, experimenting things. And that's one of the reasons why people don't really have the time to go and maintain this piece of code, right? So large classes often are business critical, but I would not say all large classes are business critical, right? We will touch upon that a little bit later. But one of the reasons is like most of the business critical classes in your source code is probably large. And then the second thing is, I think like most of us as software engineers, right, regardless of where you're from, you may have experienced this thing, right? Like you go to a company where there is problems in their code base, and you're probably a senior engineer, and then the company is going to pitch you during the interview if they really like you, right? And the pitch oftentimes goes like this: they see you performing well in the interview, they know like you are the person who can come and fix their problems, and then they would actively pitch you. They will be excited for you to come and join them. But the moment you go and join an organization, that's when they say, okay, we know like we are excited to have you here. We know you have like a lot of experience, but before you can go fix the actual problems, you have to prove to us that you are capable of fixing it, right? And this is like a frustrating problem, and it's a problem that all of us go deal with hand in hand for every switch that you make from one organization to another, or even within an organization when you're moving teams. Building trust becomes a very essential part of our jobs, right? Because even though you can deliver things, the friction for you to deliver things could be really high if the trust is not built, right? And this could take like anywhere between 3 months to 6 months to a year, and it really varies from person to person, organizations to organizations, right? Most often it's not just you; it could also be the organization culture and the kind of domain and the complexity that you're dealing with. But then building trust becomes very essential, right? And the other thing that I also want to touch upon here is, especially when you're a consultant, most of these consulting gigs they start with like a 3 month contract, right? And and time is not essentially your friend. So how do you sort of like make sure that you build this trust in a very small amount of time, but then can also deliver things in this very short period of time? That becomes crucial, and that was one of the constraints that I was facing consistently over and over when I was dealing with these code bases. So this is one of the reasons why I paid like a lot of attention working on this, thinking about this problem, working on this problem for a while. And then ramping up is also hard with really large classes. And most of the times people appreciate it when you can understand a class that is very critical to the business and then can make changes without breaking existing things. So large classes are also very hard to understand. smaller classes, most of the techniques that we use work really well, but then with large classes, it becomes a very hard problem. And large classes are also like a breeding ground for like a lot of code smells. If you look at large classes, I would classify them into a few categories. One is large because like the team did not really have the time to go maintain this piece of code, so that is why it becomes very large. And you could see things like long functions or violation of the single responsibility principle, and so on. So that is like one case where your class could be very large. The other case where a class could be very large is when we are not being deliberate about writing utility functions, right? So in my opinion, most of the times utility functions are supposed to complement functionality to the code that you don't really have access to. So this is usually like framework related code or platform related code to which you don't really have a source code. But otherwise, if you are constantly putting in things that are related to your domain data into utility classes, chances are there's missing abstraction there. So that could also be a code smell. And a couple of other times where classes can be very large are one, they model configuration files. So you could have like a lot of configuration going into your file. In that case, even though you have a large file, your cumulative complexity of all the functions in the file could be pretty low, right? So that is one other code smell. And the last case is basically when people check in generated code. I understand there are cases where you have to check this in, but when large classes are just auto-generated, you don't really have to worry about it because there is a different framework or a library that is managing this generated code base, right? So these are some of the reasons why we are focusing on large classes, because the payoff is also high, and then if you do it the right way, you can actually lower risk, managing or maintaining these large classes. And then like again, like this is going to be a subject of contention, is like, hey Raghunath, uh, why are you saying like all large classes are business critical, right? So I would like to keep this thing simple. So usually when we do like a source code analysis or a source code audit, we use like a lot of techniques by Adam Donhill. It's called behavioral code analysis, where you sort of like see how the code evolves and how the teams interact with the code base, right? So typically when you do a code base analysis, you would not pick up the code that has the highest length. You would actually pick the code that has the highest churn and the highest complexity based on the past few months, right? So that could be 3, 6 months. Really depends on the pace at which your code base is moving. So we usually use like a tool called CodeMart. So it's a tool that's available for free. You can use it. And then that has like a churn analysis and a complexity analysis. So that is something that we use to pick up the large file in the class. So we don't really pick up the one that is the largest, but there is some analysis that goes behind before you start paying attention to large classes in your code bases. So this is a very good tool. Go check it out. Could help you with your code base as well. And when it comes to building trust, right, like it's a lot more easier to build trust when you're asking the right questions. So oftentimes there is this misconception that the person that always has the right answer or the right solution to problems have it is the one who could build trust really quickly. But on the other hand, at least in whatever I've seen in organizations, that's not really true. Building trust is very easy when you can ask really good question about the existing code base or their existing systems. And it's also even better when you ask questions about tribal knowledge, right? So the tribal knowledge is something that is very, very restricted to people who are maintaining these classes. And these classes are usually maintained by like a couple of developers because they have the most context. And when you start asking questions about this tribal knowledge, which is not really documented anywhere else in the code base, then that's when like people sort of like trust you even more, right? So building trust is something that we all have to do as part of our professions. But then asking good questions is like a really good way to build trust. And ramping up, like Mala mentioned, like there are like many ways how we all ramp up to new code bases, right? Like I've spoken with a bunch of folks, asked them like how do they really deal with this problem, and then like there are interesting ways on how people do this. And if you have like a very specific way on how you're doing this to understand like large classes or large code bases, like please feel free to add them in the comments. I'm sure like a lot of people would find it helpful. So these are some of the ways how we ramp up to the code base, right? So now so these are conventional things that we do, right? Because these things are readily available to us with the tools that they're familiar with, right? But then I want to take a situation where we could say, hey, like, are these the only means that are available to us, right? Is there a different way to approach this problem? And I've been doing like a bunch of experiments for a couple of years now. And the first thing was about syntax highlighting. So when you talk about syntax highlighting, it's something that is very, very essential to almost all developers out there, right? Like regardless of whoever we are and whatever language that we use, we always find syntax highlighting very, very helpful. And one of the things that you do with syntax highlighting is when it's not present, it's extremely difficult, right? So that's why when you typically do coding interviews with organizations that ask you to do coding without syntax highlighting support, is very, very hard to deal with or like write code uh, that fluently, right? But I've been thinking about this, and then syntax highlighting addresses a very specific problem, and oftentimes we think we need syntax highlighting to write code. Of course, like I agree on that part, but then we are also used to this idea that syntax highlighting is required, or like the way how syntax highlighting is done, the current way is required to understand a code base, right? And that's why I ran an interesting experiment. So here on screen on the left, you see like there is a typical source code. It's a Kotlin source code. Doesn't really matter. And then there is its syntax highlighted and all. And for Kotlin developers out there, you'll probably be very comfortable looking at this, at least like the syntax or the structure, how it looks like. But then for Java developers, this could be a little bit confusing, or like if people are not familiar with RX Java, RX Kotlin, this could be not very familiar, right? So it's there, it looks familiar, but then it's really hard to grasp what it's trying to do, right? So as a part of this experiment, what I did was I made like two different formats of the same thing. So the one that you're seeing on the left is one thing, and then there's one more format which I will show you, and then handed it over to a bunch of JavaScript developers and Python developers, right? So this is interesting because you take Kotlin, you take libraries that they may not be familiar with, and then you show it to people that are like absolutely not fluent with these with Kotlin, right? And you could visibly see people are stumped, right? They're like surprised, they're taken aback. You could see that they feel uncomfortable just by looking at them. And people struggle a lot to read this, right? So, for example, I could zoom in and then probably show you like a closer look at it, and then you can take a look at this. So that's there, right? But what if there is an alternative way to syntax highlight code, right? Especially like one that is optimized for reading and the other that is optimized for writing, right? So here on the right side, I have like a differently syntax highlighted code, right? So one of the reasons behind one of the reasons behind doing this is I had this idea where, okay, we have a program and then we try to use natural language as much as we can to express our domain idea, or like, to solve a domain problem. But then you see the keywords and the curlies and parentheses, the symbols and APIs that are not part of your domain. So they sort of add like a lot of noise to your problem, right? And the moment you sort of like fade them away and then only focus on naming and the identifiers that you have come up with, you could probably see that this is like a lot more easier to grasp because all that unnecessary information is gone, right? So this is one experiment that I found out, and it was pretty intriguing for me because I always felt that syntax highlighting is something that helps developers understand code, and it also helps with reading code. But it turns out, at least like in a very small set of people that I've experimented with, that's not the case, right? So there is one way to do syntax highlighting if you're optimizing your code for reading, and then there is a different way you could actually try out to use when you're actually writing code. So these are very different things, and they do have visible differences. And second thing is, what about graphs, right? So oftentimes we'll start looking at source code in terms of text, right? But then like why text? Like why do we have to look at it as text, right? Because when you are looking at a class, you have members and fields and members that are fields and methods, and it's basically like a graph, right? So the way how fields and methods are related to each other, and the functions are related to one another in certain ways, and you could have recursive functions. So it's basically a graph, right? So if this is a graph, like why can't we go and visualize it as a graph, right? So that is one more exploration that I did a couple of years ago. So this is basically like an attempt to draw a class into a graph, like don't even bother reading it. And then in the beginning, it was sort of like helpful because I could see the call graph and then I could see, hey, what is connected to what. But then eventually you see that there is like the way how these things uh, the number of vertices that cross each other and then the density of the graph itself makes it almost impossible to comprehend because now there is this is worse like than what we could do with an IDE. So graphs don't even though graphs are visualization that help us uh, look at like network information, but they may not be the right kind of visualization, especially if you're dealing with like a large number of nodes and connections. So this is like a failed experiment, right? So the past one, when we talk about syntax highlighting in a certain way, that was a successful, but then this is like a failed attempt, right? But then graphs are not the only way to go and visualize, what do you call it, network information, like, right? There are other ways to do it, and one of the other things, one of the other visualization technique or like a visualization tool is the dependency structure matrix. And for those who are familiar with IntelliJ, you would have also come across their DSM tool, and this is also a very good tool. And oftentimes it helps you understand the relationship between packages and modules, and sometimes even classes. So this is one interesting thing, but then at least like from whatever I understand, you can't really do this at a class level, right? So there is no way to do this at a class level at the moment. So I was trying to just do like a different experiment where you could say, okay, let's take this thing and then try to construct a dependency structure matrix on a spreadsheet, right? So now you take all of these fields and members and then you put them on a spreadsheet and then map the relationship between them, right? So how do you map like relationship between fields and methods, and then you put numbers on them. So this experiment sort of felt promising in the beginning, but then did not really give a lot of result because one is like you are not able to see everything, and then it's all text. Like there is no visually intuitive way for us to go and understand or comprehend this own class, right? It's completely difficult. And if you keep scrolling the graph, especially when you're dealing with large classes, the graph is usually very sparse. So you would just like scroll across like entire field of cells which are completely blank, right? So in that case, you don't really want to know what relationships are absent, right? You're more interested in knowing the relationship that are present. So in fact, this kind of visualization for this kind of data is sort of, again, it's a failed experiment, but an interesting exploration nevertheless. So from whatever we've seen in the past, right? Like we've seen like a couple of experiments, and then a couple of things that stand out. One is identifiers are valuable because they make our life easier. And then the second thing is we can't really get away from the network, right? You need to know how these relationships are modeled properly, or like how every field of a member method is related to each other. So these are two things that are absolutely essential for us to understand large classes, right? So before go further, I want to take a detour, right? Because large classes are fine, but then the problem of dealing with large classes is also for us to understand these classes, right? So I came across this article, and then I was reading this, and then this thing caught my eye, right? So this is a little bit old, like this literature is pretty old. So that's why the author mentions designing programmers' work, right? So a designing programmers' work here in this context means like a person who's actually writing a new code, right? So like I'm the person who's like writing the code from the beginning, right? So that is like the designing programs work. So the quality of the match, so they're saying if you are the programmer and if you're going to create a solution, the quality of the solution that you create is basically the quality of match between the theory of the problem. So how do I understand the problem, and what is my proposal for the proposed solution, right? And if they're closer, then it becomes like a lot more easier for us to build things, right? And this is also one of the reasons why a lot of us developers enjoy writing new code, because you have a problem statement that you understand reasonably well, and then you also have a solution for the same problem. So it's entirely under your control to build solutions that work really well, right? And that's also one of the reasons why when you're working on new code bases, the initial traction or the pace at which you deliver things is super high, because there's like not a lot of other variable elements that are involved in the code base. right? Now, the tricky thing is what happens when you inherit a code base, like a code base that someone else has not written, someone else has written, and then now it's your job to maintain that piece of code, right? So then what happens? So in that case, if you are a programmer that has inherited code base from someone else, then the quality of your work is going to be determined between your understanding of the theory, your theory, and how close your theory is to the theories of the previous developer, right? So if I'm going to update a solution, if I'm going to enhance a solution, or if I'm going to work on someone else's code base, then I not only have to understand, I have to figure out that the theory or like the understanding of my previous maintainers so that I can craft my solutions that will actually fit into the problem space, right? So this is the hard part, right? Because now it's easy in cases where you have this developer sitting right next to you, right? You have a developer sitting next to you. You could just go and ask them, hey, like, what does this do? And then they could tell you, and that's pretty easy to get done, right? But then what happens when you don't have this person in the same room or like the same office, or like not reachable because they're on vacation, or like they just like moved companies, right? So then that becomes very, very hard. And this is not a new problem. Like companies have known this problem, and then we do handoffs, right? So typically, technically, a handoff is basically how does the previous maintainer pass this knowledge to you when they're moving to a different code base, right? Like when they're leaving the organization. And there are many ways how companies do this, right? They get onboarding programs where you get onboarded to their architecture or like the code bases, their documentation that your previous maintenance would have written, their tests, their comments, their Git history, the working software. There's like a lot of different stuff, but everything is sort of scattered all over the place, right? So if I'm going to work on a specific class, then how do I get all of this information in one place? Because ultimately the source code is the place where we have the truth, right? Like that's the absolute truth. There's nothing else. So, in my opinion, what helps in this kind of situation, right? So, the first thing that I would focus on is the vocabulary, right? So, when you take a class, the class has a vocabulary, right? And then there are obviously relationships that are part of the class. You have fields, methods, and then they're like related in some way. Like you're either reading the fields, writing the fields, or you're calling functions, or you're referencing a function, right? So there's like a lot of stuff that's going on here. So these are the two things that you'll always find in a code base, right? And it's already there. There's not a lot of work we have to do. The third thing is prior exposure to the problem domain, right? So if you're working on a class or if you're working on a code base, if you have the prior experience, but not as a developer, but even as a customer, right? If you've used banking applications, if you have used food delivery applications, if you've used transportation applications, ride hailing applications, these are domains that you're already familiar with, right? And this is something that could be like an advantage if you're going to work on a code base where you have prior domain exposure, not necessarily as a creator, but even as a consumer, right? So for three, there is no easy replacement, but the vocabulary and the relationship, like if you have a good understanding of the vocabulary and the relationship, you could still go ahead and then capture three over a period of time. And then like we can talk about tools, right? Like different kinds of tools that we have. And there's a microscope, there's a magnifying glass, you have binoculars, you have telescope. And then these tools have very different reasons depending on the kind of objectives that they're trying to achieve, right? And more often than not, we sort of like get stuck into very limited tooling that we use, and more often, and often that's usually our IDE if you're working on a source code. But can there be a different way, right? And maybe. So one day, you already know like a bunch of visualization that I showed you, and then none of them worked, right? Like there were like fun experiments to do, but then none of them gave us a very good result of what we wanted. So this website, Observable HQ, is one of my favorite websites. It's a data visualization website. You may ask like, what business do we have of software engineers like looking into data visualization, right? Fair point. One of the reasons I think most of you would be related to is trying to convince your team to pay off technical debts, right? And oftentimes, organization ask you for metrics that they can track to, one, bring visibility into the problem, and two, to see how much progress you have made, and then to find out if you have completed a project, right? So in these things, I as a developer struggled a lot, right? Like I know there was a problem, and like most of us know there is a problem in our code base. We know, like we have this intuition that tells us something is wrong, and oftentimes like our peers also feel it. But then when we are asked to articulate the problem, it becomes very, very hard to articulate the problem, right? So there are ways how you can gather data about your source code. Like there's Git history, there's static analysis. You can use tools like JQ Assistant that lets you query your source code, and then now you have this data, and then it's a CSV, or like it's a boring chart or like a tree map. But then if you can figure out over a period of time to take a particular piece of data that is related to your source code and then apply an appropriate visualization, it is a lot more convincing to sell this to whoever is responsible for giving you bandwidth, right? So this is one of the reasons I got into visualization and data visualization, mostly inspired by Adam Tonhill's work. And then I was looking at this website one day, and then I came across this strange looking graph, right? So this is it's called an edge bounding graph. It's a very strange looking graph, and if you zoom in, this is a graph that is visualizing the characters of a French novel. Apparently, it's a very popular French novel. I've not read it. And if you look at it, it's basically you have a bunch of characters, and then these characters are grouped into several groups, right? It's probably representing families or clans that they are a part of. So if you look at this, and then you see like there are like multiple groups that show up here, right? And then here, if you also look at here at the bottom, you could see we have reds and greens, and then other stuff that's going on here, right? So basically, red means they are your dependents, and blue ones are your dependencies. Like that's what it depicts. So this graph sort of like helps you look at the bigger picture, right? It gives you like a bird's eye view of what is going on. So this is quite exciting. So this sparked an idea of like, why can't I sort of use a visualization like this? Because if you look at a class, there are two kinds of members, right? One, you have fields, and the other one, you have functions or methods. Now, these are two different groups, right? So you only have two groups when you're dealing with a class. And if you can group them together and then map the relationship between each other, will that make sense, right? So that was an interesting thought. And of course, I explored that area. We'll see what happened. So from some of our previous experiments, we know like two things, right? We know identifiers are valuable. We also know we can't ignore the network, right? So with this edge bounding graph, like this visualization, now we can sort of like deal with this complexity of this network in a more reasonable way rather than using other visualization techniques, right? The other one is vocabulary, and there is this thing, vocabulary. I was like, I didn't know what vocabulary is. Meaning like I know sort of know what it is, but then I really wanted to look up the definition of what it is, and it basically says it's all the words that exist in a particular language or subject. Like that's it. Like I was expecting more, but that's it. So when we talk about vocabulary, so a class can also have its vocabulary, right? Because it's us trying to model problems in a natural language, right? So when you talk about vocabulary in a class, there are only two things. One is types, right? Basically, types are super interesting because they somehow model your problem domain, right, in certain ways. So types are very interesting. So we have a bunch of types here. So void, long, story post. So story post is like a lot more interesting here in this use case, right? So what we do is we take the types of fields. So you have a field, then there is a type field, and then when you look at a function signature, you have the return type, you have the parameter type. So those are the types that we are interested in, right? So we're just going to collect all of those types, right? And the second thing is identifiers. So we also know identifiers sort of make code more readable, but then identifiers also are the way how we express things, right? So this is also something that we need to collect, right, to see what is going on. But identifiers themselves can be very unique, except if you're overloading a function. Otherwise, like they're usually very, very unique, right? And then when you have like a lot of unique ideas, they don't tell you much, right? But then even when you have unique ideas, what I want you to pay attention is the camel casing, right? So when you have camel casing, you know like these are very different words, and if you're working on a problem domain, you are supposed to use some of these words more frequently than the others, right? So what we do is we take those identifiers and then we convert them into words. So we take a bunch of identifiers and then say, okay, this is a camel case or this is a snake case, regardless, and then we just like break them down and then we put them, we treat them separately, right? So on one hand we have types, and on the other hand we have these identifiers that we break down into smaller words, and then what we do is we just like count them, right? So now when you start counting them, now you get a bunch of types and you have a bunch of words, and that is sort of getting interesting because now this frequency will tell you what kind of things that you need to pay attention to. Like that sort of suddenly shrinks the amount of things that you have to prioritize to start looking into your code base. So from with this thing now we know like identifiers are very valuable, and then now we also have a meaningful way to tokenize them to not break types because we keep types intact, but then we break identifiers so that they can give us more interesting stuff. So I'm done with the fundamental parts here. Like the everything that is left is the demo. We have to probably do a demo with the tooling and some more demo with the what do you call it, IDE. So if you have any questions, I'm more than happy to answer. So Mala, like, do we have any questions that we need to look into at the moment?
Hi, Raghunath. So we have a couple of questions, but most of them are regarding so one question which we got initially was how to make sense of the code bases when there is no documentation. So I think you are talking about the vocabulary, and that would answer some of the parts of that. So if you want to elaborate on that question, I think yes.
Yeah. So I like the word documentation here because I think it gets used often, but then a documentation is a means to an end, right? So if you look at
Right.
documentation, what we're primarily talking about is knowledge transfer, right? How are we doing knowledge transfer from someone who has actually authored this code to someone who's actually maintaining this code now, right? And the documentation, the best documentation someone can write is actually the source code that you're dealing with, because that source code is the absolute truth of whatever you're doing, right? Because when you're talking about documentation, then there is another problem of synchronizing these two, right? So you have a documentation and you have this code. Like, how do you keep them in sync all the time, right? And even if you read the documentation, like, how can you sort of like uh, uh, trust it, right? Like, how do you know like it's absolute or like it's constantly keeping being updated, right? So those things can be very tricky. So I would rather like focus on the absolute truth and like try to be as close to the source code as possible, because that tells you everything. Like, you can do a static analysis or you can also do a runtime analysis and then see how the code behaves in production. So that is your truth. So if we have tools or ways to look into those aspects of a program or like the qualities of a program, then it becomes a lot more easier to deal with these things. So basically, documentation is
That
knowledge
makes
transfer.
sense.
Yeah, yeah.
So if we talk about the code comments, do you have any interesting experience because they are closer to the code? Are they closer to the absolute truth, or is that a myth?
So I'm blind to code comments oftentimes. Sometimes I keep them around, sometimes not. But oftentimes I think like one of the interesting things I found code comments useful was like a few years ago, where we would just leave funny messages for other developers to find out. Right? It would just like be some funny message, like not very helpful. But just like you're having a bad day at work, and then you're opening this piece of code, and then you want something to look at and smile at. Right? I think like that is an excellent use case for code bases, like code comments, and I try to use them for those things. But then with one of my clients, when we did that, it suddenly got out of hand because some suddenly people start being mean about the jokes. So we said like, okay, you're not going to write any codes that are not related to the code base. So I find comments absolutely helpful when you are shipping libraries for external folks, right? So if it's an open source project, and then I try to document public APIs as much as I can. But oftentimes, the way how I try to understand code bases that are not I'm not familiar with is to look at tests, and if there are no tests, I try to write tests on my own. So that's one of the ways, and scratch refactoring is one way how I try to use it. But documentation, I think it's very hard to get it right, and especially to get it right across the entire team, because now you have language barriers, right? Like if you're not like a country that speaks the language as your first language, then you're dealing with like a lot of different people, and things that they say could mean things that are very different from what they mean, right? So I don't
Right.
really like depend on comments like a lot. I try to avoid them. That doesn't mean that I say they're useless. I find comments very useful in public APIs, and well written documentation is very helpful, regardless of that. But that is not something that I primarily rely on. Probably because like working with legacy code sort of takes away the trust from you. Like, okay, like I'm not going to trust this piece of comment. But yeah, that's my stance about comments at the moment.
That's interesting, and I know that phrase can be kind of understood in different ways across cultures. So there's
Yeah.
another question which is related. So I'm not sure whether the person is using their real name or is that another handle, Mim Ko Ren. I know I
Right.
did pronounce that incorrectly. But the question was
Oh,
how, so the person is curious about how to navigate not just a large class, but rather an entire library, since often navigating unknown code means jumping between classes. So, first question is maybe that's a bad idea with a question mark. And probably I believe the user wants to know how to go about that, navigating multiple
okay.
classes.
So that is an interesting thing. I have a very specific way to do it. There is a different kind of tool and a different kind of visualization to do it. So the whoever wrote this down, you can reach out to my DM on Twitter because I can share a tool with them. Because it's not in a quality where I could publish it to GitHub, but I'm more than happy to share the tool. So it's basically a sunburst. So oftentimes people, the way how we navigate classes is either looking at the directory structure, and then the directory structure does not have many dimensions to it, right? The only dimension that a directory structure can represent is depth, right? You could say like how nested a file is or like where it is located, but it doesn't really give you a entire picture, right? So if you are navigating a library or a project and you have multiple classes that you need to deal with, one way to do this is to use a sunburst diagram, right? Because the sunburst diagram can show you like a size of the directory as well, right? So that is one thing that is interesting. And the second thing is you could also use things like UML diagrams to find out relationship between classes. So that's a tried and tested visualization that we already have. So I'm not really sure what this person is referring to, whether it's like looking at the entire project, because we have ways to visualize the entire project as well. And there are also ways to visualize relationship between classes, which is like the static relationship uh, between the classes, language level relationships. Yeah.
So I have a follow-up comment by the same
Oh,
person who
yeah.
asked the initial question, which is the
Okay. Okay.
vocabulary usually means reading the definition of a type, and then you find yourself going between classes.
Correct.
So
Correct.
probably I think you answered that right. Yes. And we have another comment in which Robert agreed. Yes, the
Yeah.
documentation goes out of date quickly. So you talk about the mismatch between what the code does and what it says it does. So yes, that makes sense. We have another question about impact analysis and how what happens or how do you determine when you change one section of the code and how it affects the other part of the code. Do you want to take that question now, or would you like me to kind of complete your presentation and we could
That's
take
a
that
very
towards the
interesting. Yeah, that is a very interesting
okay?
question, but I think we
Okay.
can hold on. That I have some thoughts around it,
Okay.
but yeah, let's do it later. Yes.
Okay. Sure. So I'll let you continue. Have fun.
Thank you, Mala. All right. So now we looked at a couple of ideas. Now we're going to take a look at a demo, right? I hope you folks can look at this, right? So like a couple of things that we talked about, right? One is something that we talked about vocabulary in terms of types. And there's this question, someone said like, hey, when you're talking about vocabulary, there are like a bunch of classes that you need to look into. What do we do about that? Like that is an interesting question as well. So this is a tool. This is an open source tool that you can use. It's part of the experiment. So the way how this tool works is basically it looks at your class files and then determines the relationship between them, right? I'm just going to walk you through the tool to get a help you with getting familiar with the tool itself. So the first thing that I'm going to point out is basically this one, right? On the top, you have a legend that says red and blue. So red are your dependencies and blue are the dependents, right? So this basically it helps you map the relationship between fields and methods, or methods and methods between them. So this is the fundamental way how we are going to say who are my dependencies and who are my dependents, right? So that is one thing. I'm sorry about this. The second thing is like it sort of gives you some stats about the current class itself, right? Like how many fields are there, how many methods are there, and how many relationships are there. So this is a number that is helpful, but I would not get too hung on these numbers, right? Because especially they come in handy if you're trying to refactor classes, because now you can see which numbers are going down and which numbers are going up, right? And one of the things that we have to remember when you're like trying to understand a class or like we're trying to refactor classes, these numbers like they don't mean anything, right? Like they have no absolute meaning at the moment, right? Because if you have 61 methods and you probably have to extract 5 more methods, which will make your code more readable, then you should do it, right? Like regardless of whether this number goes up or not, because the primary reason of refactoring is to get more clarity about the code base and like not to keep these numbers down, right? So that is like a side effect of you doing a good job breaking down a class. But then these are numbers that are there for your reference to just to keep a track on what you're doing and the kind of effect it has on your code base, but please try not to get too hung up on this, right? The other one is basically it's the name of the class itself, and then if you hover, it's just going to give you the entire package name. One of the things that we sort of like find it hard to pay attention to is when you're looking at a source code uh, at a class definition line, class declaration line, then we tend to sort of skim most of the details, right? So we don't really pay attention. We probably pay attention to the class, probably the superclass, but then oftentimes there's too much noise, then we just like skip looking at it, right? So here, what we wanted to do is like we wanted to give you like a nice little summary of what is going on. So here, I know like okay, this is something called as a story viewer page fragment. It's fine, and then it extends a certain other fragment, and now it also implements a bunch of other things, right? So now it helps us to focus on these things. So the first thing that you notice is like most of them are callbacks, right? So you have 5 interfaces, and each of these interfaces have a callback suffix, right? So which means this activity has at least 4 other components that it's interacting with, and then those are giving results as part of the interaction. And there's also one more thing, which is an events interface. So when I start looking at these things, at least in my head, I think the callback is sort of an output as a result of an interaction, and then the events or inputs, right? So now this is the first time I would probably go and write down on a piece of paper or like on a notepad and then say, okay, as per my understanding, I can see there are 5 different interfaces, and then 4 of them are callbacks and 1 is an event. And right now I'm guessing that the callbacks are outputs for interaction with other components, but then the event is an input, right? So that is how I would sort of like write it down. And this is a question that I need to verify with the actual code base, right? So one of the things that we try to do is when we look at all this information that is presented to us, we sort of try to come up with interesting questions, and then we sort of map them down on a piece of paper, and then we go into the IDE and look at it, right? The tool is not a replacement for your IDE. It is supposed to be a complement to your IDE. So you are supposed to use the tool as a complement to your IDE, and the tool is for asking questions, but your IDE is for giving you the answers, right? So that is one thing. And the second thing that I would also look into is basically the number of implementations that we have, right? So for every interface that we implement, that is one additional responsibility to the class. So in this case, it's 5, but I can't really say, should I sort of like not implement them and then use composition over inheritance? So that is something that it's too early for me to decide, but then I would pay an attention on this, right? And in this case, there is some consistency among the callbacks or the interfaces that we are dealing with. But if you end up looking at like a lot of different interfaces that have no relationship with one another, chances are the class could be doing more than it needs to do, right? And those interfaces could probably be broken down into smaller classes. But that is something that you need to pay attention to, because what is the relationship between the classes, or like do these interfaces represent the same idea, or do they represent completely different ideas? So that's like a very quick summary of the class, and then we are only focusing on the types that we are dealing with here in this class, right? It makes it more prominent. And then on the right side, this is what I would call the vocabulary, right? So the vocabulary here in this case, there are a few filters here. The first one is basically trying to display the vocabulary, which is basically your types and the words that we found out, and it does it for all the methods and the functions in the class. But then you can still filter it based on state. So when you do state, then that only represents your fields, and then behavior will represent only your methods, right? So let's sort of like take a look at that. So one of the things that I would try to look at is, for example, let's start with all. And then if I look at it, I think like the question was like, hey, we have to navigate between classes. How do you decide which classes to navigate to, right? So in this case, when you start looking at it, the first type that shows a lot is like a void type, right? And when you deal with void, that is a very interesting return type, because if a function is not returning a value, then it's probably performing a side effect. It's not probably, it is actually performing a side effect, right? So now if you have like a class that is side effect heavy, then what are the possible things it could do, right? It could probably be updating the database, writing log statements, making dispatching analytics events, like updating the UI, or writing to a file. There are like a bunch of, it could also be a mutation, like we don't really know. But then the moment you look at the void type is the highest one, you know, like this function, this class in particular is doing like a lot of side effects, right? So that is one indication that, you know, there is like a lot of side effects going on. The second thing is looking at story post, right? So when you look at story post, so this is one domain concept that has been eloquently expressed by the previous maintainers. So now I want to know, like, okay, there is this class called story post, so there is something that I need to find out about this class. So this is an important class in this. This is one of the important dependencies in this class. So I would note this down on a piece of paper or on a notebook, and then I would say like, hey, let's go take a look at it, right? So let's try this out. Let's say if we have found out story post is one of the most important classes here. So that what we do is we just go to the IDE and then we say story post, right? And then if you look at it, now this becomes very interesting because now you have story post, and then it's a data class, but then the data class also has a sealed class in it, and then the sealed class has content, which points to a URI, and there's text content, right? You have a sealed class, and then the sealed class has an attachment content and a text content, right? So that gives you some idea about the story post itself, right? So now you have like okay, this is an important class, and this class is probably dealing with attachments and text content, right? So that is already information that we know, and then we have not spent like a lot of time doing it, right? So we know like story post can have attachments and text, so that is one thing. And then the other thing is what makes me sort of like slightly worried, especially when I see like primitive types having like a very large count here, right? So here it says long, and oftentimes why primitive types worry me is because sometimes we are obsessed with primitives, right? So we don't model primitives correctly, and that is one of the reasons why primitives should show up like a lot in this case, right? And then there's like also a bunch of other stuff. There's text view, a string, and like a bunch of stuff that has to deal with types. And if you scroll down, then we have words, right? And if you look at words, there is on, right? So on gets called 15 times, and that is sort of like a little bit strange, right? So what I can do is I can click on the on, and then I can zoom out, and now you could see we have highlighted like a bunch of methods that start with on, right? So now you see there is on state changed, on the state, on start direct reply, on show caption overlay, on resume, on ready to animate. So now when you start looking at these functions, these are all side effects, and these all start with the on prefix. And then now, if you remember, if you go back to the implementation of our the classes, the interfaces that we implement, it makes it more clear. Sorry about that. I have no idea how to get into this. Yeah. So most of these are from callbacks, right? So the on keyword matches with our callback heavy model that this class exhibits. So there is that. So we have like a bunch of things that are related to callbacks, and there is a getter, and there is present, and there is story, right? So story again. That's not something like so. So if you look at this, there's present. So that is an interesting idea. So we don't really know what present means. So that is something that we should find out, right? So now I've selected this word called present, and that is an idea that I want to know. Like, what does this? Why does this say class say present, right? So I can zoom out, and then I can zoom into the graph. Sorry. And then if I look at this one, this part especially. Sorry. Oh, I have trouble zooming in, zooming out. So you see there is present replies, there is present story, there is present slate, there is present center avatar, there is present group avatar, there's present from, present distribution list, present date. So this is something to do with like showing things on the UI, right? So clearly the present keyword is used with the same context in all these places, right? So I can also tell that because if you look at this function signature, all of these classes also use the same story post here, right? So we know like this story post is one of the important types in this class. And now we also see there is this present idea. So I don't know what that means, but I'll have to go look into the source code to see what present means. But then present is also linked to the story post. So that makes it slightly more interesting because this class's most important thing is the story post, and then most of the side effect happened on the present. So it's probably like a UI related stuff that has to go on with the story post. So those are some of the ideas. So what you do is basically start looking at this vocabulary, like sort of see what is going on and stuff. The other central element of this entire thing is basically your graph, right? So you have this graph, and then there's like a lot of things going on. The first thing that you could see is there is a division here. So if you look at the graph itself, there is a division that starts here, and then it ends here. I'm sorry. It starts here and it ends here. So this division is the division between your fields and your method members, right? So this one on the right, so the one that I'm pointing to, that is your field, and the rest of it is your method, like at the bottom, right? So that's why they are clustered in two different places. The other thing that you notice is when you sort of highlight on one of these things, right? You would see there are blue lines and there are red lines, right? So a blue line essentially means that someone is depending on you, like someone requires you. Those are your dependents, and the red ones tell you your dependencies, right? So these are your what do you call it? Like these are the things that you require. Like say for example, present slate requires both story slate, and story view page fragment. So that's one of the things that you will notice, that you have blue and green ones, right? So the interesting thing about green ones is basically, sorry, the blue ones is basically, if you start looking at your fields, the fields usually don't depend on anything. They're like almost self-sufficient. And you would see that like a lot of other classes depend on these, other functions depend on these things. So this is one characteristics that you have to keep aware of, because when you see a blue one, blue ones are have no outgoing. Sorry, they don't have dependencies, which means if you want to move them to a different class, it's going to take a lot of effort, right? So that is why blue ones can sometimes be hard to move to a different class. And then what else do you see here? So and then you have the red ones. So basically, if you start looking at the red ones, this one does not have any blue ones, which means it does not have, it only has dependencies. And the moment you break the dependencies, you can move this out to a different class. So those are some of the colors that you could see. And there's also like a bunch of numbers that it shows. Like one is the signature of the field or the method, and then it also shows you dependencies and dependence, and then the effort that it requires to move these things out. So that is one thing. So the density of the class, again, like say for example, look at on view created, this depends on like too many things. Like there are like 53 dependencies for this one. So it calls like so many functions and accesses so many fields. So for example, in terms of impact area, if you change any of one of those functions, this is one function that could get heavily affected. The more dependencies that you have, the more chances of it breaking, right? The opposite is also true. So if you do something to your a member that is used by a lot of other members, it's also easy to break stuff, right? So extreme blue and extreme green have extreme blue and extreme red have those qualities in them, right? The other thing is like one of the thing is like when people look at this graph, people ask me like, is there an ideal graph, right? Is how does the ideal graph look like? This is a dense graph. Like if you look at classes that have very few responsibilities or like very few fields and members, they are like less dense, right? So I've been looking at this for a while, and then one of the qualities that I've observed with classes that don't have they do not violate too many responsibilities, or they have too many responsibilities, is not the presence of something. It's an absence of a subgraph, right? So if you look at this entire network of classes, and if you start traversing them, right? Like say for example, if you start traversing this relationship with this field and its method, and now you are, if you're starting to traverse this relationship with this function and another function, which is basically your call graph, you would end up with smaller subgraphs inside the class, right? So if your class is doing too many responsibilities, there are chances where you would see these independent subgraphs existing inside your class itself, right? So if your graph does not have any loosely coupled subgraphs, then it means you have a class that adheres to a single responsibility, and often these classes also have a symmetric structure in them, right? So that is one way like I try to navigate the class. So for us as a sample exercise, what I also want to do is identify a network in the graph itself, and then try to uh, refactor it using IntelliJ. So that is something that I want to show. This like it really depends on how much time you spend on the graph, and then like the kind of question that you ask that actually pays a lot of result. So right now, what we can do is we could actually try to figure out a subgraph, one of the subgraph, and then try to split it into a different class, right? So and then see how that would look like. So the first thing that I want to do is this Chrome thing, right? So when I click on Chrome, there are like a bunch of qualities here, right? So this is like a field that has a name called Chrome, and then there is this other field that calls show Chrome, which is again it's a method, and then you have other interesting things, right? When you click on Chrome, you have a few more methods on the bottom that says hide Chrome immediate, hide Chrome, and then animate Chrome, right? So one of the things that is also a giveaway is when you're dealing with classes that have common suffixes or common prefixes, or if they use the same terminology, they are representing the same idea, right? So in that such situations, if you traverse the graph, it's easy for you to see if there is an independent network that is inside the class and then try to pull it out. That's one of the things that you could do. So paying attention to common suffixes, prefixes, and common terminology is one quick way to understand or separate responsibilities from a class, right? So let's say let's take a look at this. Let's try to do what we are trying to see. So right now our assumption is okay. There is this class called there is this field called Chrome. So we're going to try to pull this out, right? So first thing that I'm going to do is I'm going to go to this text editor and then I'm going to say field Chrome. Right? So that is one thing that I am going to pull out, right? So the next thing that I'm going to see is what is the relationship with Chrome with other members in the class, right? So if I highlight on Chrome, it's going to say there are three things that are dependent on it. And I'm sorry, like I couldn't zoom in because like the click to select is not implemented. But at the bottom, you could see there is hide Chrome immediate, and then there is animate Chrome that depend on Chrome, right? And then there is also on view created. So there is one other special relationship. But right now I would just go and say hide Chrome immediate depends on Chrome, and then animate Chrome depends on Chrome, right? So we would say hide Chrome immediate and animate Chrome, right? So I'm going to say hide Chrome immediate and animate Chrome both depend on Chrome, right? So that is interesting. So now the next thing that we're going to do is like we're going to take these. So basically, you're doing a search, right? You're going to say, okay, if I want to pull this animate Chrome, what else I have to have it deal with, right? So in this case, we have to deal with hide Chrome, and we also have to deal animate Chrome also has to deal with animate reset, right? So that is interesting. So if you look at hide Chrome, animate hide Chrome, there is one method called hide Chrome which depends on it. There is show Chrome that depends on it, and then there is an animator set that is a dependent for this one, right? So we could say hide Chrome. Sorry, there is hide Chrome. So we could say I normally write this on a piece of paper, so it's very hard for me to type. So this is one relationship that we see, which is basically you have animate Chrome, and hide Chrome immediate. So the next thing I'm going to do is I'm going to see what does show Chrome do, and then show Chrome is called by view created, nothing else. So that is fine. And then if I go look at hide Chrome, then we could see again there is animate Chrome, that's like again within the same network. And then if you look at hide Chrome immediate, again you could see there is animator set and Chrome, right? So for all of these fields that have Chrome in their name, we could see they depend either on Chrome or they depend on animator set or both, right? And oftentimes these are called from on view created. So that is like the relationship that we have determined. So once you know these are all the fields that we're dealing with, it becomes a lot more easier for us to pull these things out, right? So to do that migration, I am probably like we're running out of time, but we will try to do like a little bit of refactoring to see how this looks like, right? So we want to pull Chrome, the animator set, and like a bunch of other methods that are related to it in a separate class, right? So let's switch to IntelliJ idea. So here I'm going to go to story view pages fragment, and then we could also go to the Chrome thing. Okay, so this is what we're interested in. So one of the things that we see is we need to sort of say we clearly know this is a separate subgraph, and then we need to pull it into a different class. So what we are trying to do is how can we make that happen, right? Because we also know from the graph that Chrome has the highest stability, which means it has no outgoing dependency. So it's if you want to move Chrome, that can be the last item that you could move from the class, right? But then for all the methods also depend on the Chrome class thing, right? So the first thing that we're trying to do is see how can we do a parallel implementation so that you have an existing implementation which is inside the class, but then you're also moving all of this part of this functionality from the existing class to a different class, right? So that's what we are trying to do. We are trying to create a class and then move this entire subgraph. It's because it's a separate concern into a different class, right? This first thing that I'm going to do is use IntelliJ's refactoring tools as the primary driver, and the second thing that I'm trying to do is to use a Git GUI to constantly keep looking at what I'm trying to accomplish here, right? So the first thing that I'm going to do is I'm going to go here and then I'm going to say I'm going to create a new class, right? So I'm going to say some Chrome class. That's what I'm going to create, and and then once I do that, I'm just going to commit it immediately, right? So see, I'm just going to say uh, refactor, right? And then I do a double bang because this is something that I've manually edited, right? So since I'm editing the class on my own, I just want to do a double bang here. The reason for doing this is because when you are trying to get your code reviewed, especially when you don't have tests to do this refactoring, is to make sure that you're like not typing too much, but then relying on the IDE to drive most of your refactoring. So I would just say create a new class, right? And then I would just commit it, and then I would just go back to the IDE again, right? So now what I'm trying to do is I'm trying to move things into this class. So first thing that I need to do is create a parallel implementation. So what I'm going to do is I'm going to go to the Chrome thing, and then I'm just going to put this class pretty close here, right? So I'm going to say this is a late init. I'm also going to make it a late init, right? So I'm going to say private late init var some class, some Chrome class, right? So that looks good. Again, go to the thing and then say r create a field. This way, you can separate refactorings that are high risk from the ones that are low risk, right? The other thing that you need to do is now to figure out the reads and write relationships for this class, right? So first thing that we're going to do is we're not interested in the read relationships. We are only interested in the write relationships. So if you see who's writing to the Chrome class, you could see there is this one function on view created is actually writing to the Chrome class, right? So what we do is we just go there and then see, okay, so this is a class that I have, but then if I'm starting to move functions to a different class, then I still need access to this thing, right? So what I'm going to do here is I could say some Chrome class, right? I can instantiate here and then call it some Chrome class and then pass in the Chrome as a parameter, right? Now your ID is going to complain, the compiler is going to complain, but then you can do a add parameter to the constructor, and then you can just like add that and like not too much. So now everything looks good. I go back here and then I look at it. So I use the ID's change signature to introduce a parameter. So now I'm still going to say instantiate some Chrome class, right? So that goes here. So what we do is like we do micro commits here. So one is we're calling out all manual edits because it's easier for reviewers to review, especially if you're in a position where you can't add tests. And the second thing is if something goes wrong, you can just like still keep most of your progress and just like discard the ones that are not really required, right? And then we go back here and then see, okay, this is good. What else can we do, right? So the next thing that I'm going to do is I'm going to go to the I'm going to go to the graph and then see we have Chrome here, right? And then we have animate Chrome, but then that is not enough. That's not easy to pull out because it depends on too many things. You can go to hide Chrome. That does not depend on Chrome, so that's not a problem. And then you have Chrome here. But then if you want to remove hide Chrome immediate, then you also have to break a dependency with animator set. So I think like for now, I think this is like a reasonable way because we have access to Chrome, and if we have access to animator set, we could actually move this hide Chrome immediate function into the different class, right? So the next thing that I'm going to do is I'm going to take a look at the animator set, right? So this class right here is what we're going to focus on. It says animator set. Let's go to the IDE and then again do animator set. And then this is interesting. Again, it's the same playbook. So we do see who's writing to it. And then this is writing here, right? Now this becomes slightly tricky because this is not inside on view created. And this has put us in a position where it's not a desirable position to be. But I think we can break this dependency. Shouldn't be a problem. So we'll do a couple of steps. So the first step is for us to extract this into a separate function. Right? So you could extract it as a function and then call it as create new animator set, or you could say new animator set, right? So that looks fine. Sorry, but okay. So when this something like this happens, you just do a git checkout dot because I have no clue what I did. So if you're not really sure what changes happen to your ID, then you probably should do a git, right? So now this is interesting because when I pull this out as a method, right, and I just call it X or whatever. Now, there's an interesting thing because the IDE may sometimes have limitations. So when you're trying to extract a function, oftentimes what you have to see is you have the function extracted properly, but then it should also compile, right? In this case, it's not compiling because maybe the IDE does not understand what is going on here, right? But especially with respect to the animator set. So I'm just going to do a dot return type here. And then this is just like throwing more errors. So I'm like not really comfortable doing this. I would just go ahead and then just get rid of the change. Uh, right. So now I'm trying to see if there is a different way to actually deal with this problem, right? Let's try to do one more thing. Let's do extract variable, right? So that is a extract variable. Uh, okay, let's take a step back here. This is a tricky dependency for us to break because one is there is mutation here, which means we need a setter that will set the value here. And then the second thing is we also need access to the animator set. That is interesting. So let's try one more thing. Sorry. Let's try to pull this out as a variable. Let's do that first. Let's say a new animator set. That is fine. And I'm going to go to the GUI and then see if like the changes look reasonable. And this is an ID as a refactoring. So I would just say R extract introduce variable, right? And then that's done because that's a safe refactoring. The second thing that I would probably try to do is like to break this dependency, right? So this is a dependency I want to break. So what I can do here is I need a getter and I also need a setter, right? That becomes tricky. So if I need a getter for this one, I could say this dot invoke. So when you do this dot invoke, right, you basically the lint is telling you, hey, this is written lambda. Like you don't really like have to do this because you could do something more simpler, right? And if I inline body, I get the previous thing, right? And the other thing that you might have noticed is like this little the little marker on the left that tells you what is going on, right? So what we do is that is a good indication that when you inline the body, you end up in the previous state, right? So that means like that is a provably safe refactoring. So the first thing that I'm trying to break this dependency on this function is to sort of create a getter. So I know like I need a getter here. So I'm going to do a invoke here. So now this is a safe refactoring because one, the linter tells me it's safe. So I'm leaning on the linter and using this information and I'm going to mark this as return at lambda. Right? That is done. And then now you could actually extract this into a variable and say animator, this call it setter or animator setter, right? So your setter, again, that's introducing a lambda. So introducing a variable. Uh, so then you say that's a safe refactoring because the ID is doing it for me. And then you could actually go and do the extract function, right? Sorry, introduce parameter. So now what we've done is we've taken this dependency and then we've converted it into a getter and then we've pulled it out, right? So that is an interesting thing because now you could actually break this dependency and then move this into a different place, right? So now I'm going to commit this. It's also a safe refactoring thing. So, you know, like the ID did the a good thing for you. So what you can see is you have the actual function changed and you also see the call site being changed, right? So that's a good thing. And you don't have compilation errors. So this would again be, this would be change signature. We call it introduce parameter, right? And then that is gone. The next thing that we need to break is this one. This is the setter, right? So this becomes slightly tricky. So so this one, what we do is we create a return lambda, right? So we do invoke. Sorry, that is a return lambda. Oh, sorry. What did I do? What did I miss? So I am trying to do okay, and I'm going to call invoke, but this is complaining. I think that's happening because I need a semicolon over here. Let's try it out. Then we can just take it rid of stuff if they don't work. Yeah, that's because this is treated as a parameter to animator set or the apply function. So what we're going to do is git checkout dot one step at a time. We're going to add a semicolon here, and then we say style add semicolon. Then we go back here, and then we introduce a redundant lambda here, invoke, and that is good. Our redundant lambda, and then now it becomes more interesting because this is a setter, right? This is a setter, and what we need is an animator set, right? So what I'm going to do is if I want to break this dependency, I have to pull the setter outside the function, right? To break that dependency, what I could do is this is at the moment it's an action 0. What we want to do is we have to make it an action 1, which means it's a lambda that takes no parameters and returns no value, right? But we want to convert this into a lambda that takes a single parameter and returns one value, right? So what we're going to do is this is the one that we need to pass in. So I'm just going to copy the same identifier, put it over here, and then call it animator set, and then do that, right? So I'm just going to, I'm going to stop here because now I know this is a redundant lambda. So what we've done is we've actually parameterized the lambda. That's what we've done. So we take this local variable and then pass it as a lambda parameter. And again, this is also probably safe because if you go and do an inline using your IDE, it's going to take you to the previous state. It's not undo. It's basically a transformation. So it's like not an undo operation. So that's why we say we made this change, but then we apply a different change on it. Then we land at the previous state, right? So this one is again parameterized lambda. So whenever you have when you use the IDE to make the changes, you just mark it with R so that you know these are safe changes. Now this is the variable shadowed. I'm just going to rename this to animator set. Or I think I'll call it animator 1 because there's going to be a name conflict. It's fine. We can always rename it later. So rename parameter. And then what we're going to do is now this becomes more interesting because now you can pull this into a variable. Now this is your animator setter. Okay, the name's strange, but that's fine. Right. Then what we do is we say, okay, this is a safe refactor. ID did it for us. Introduce variable. Then you go back, and then this becomes interesting because now you could do a introduce parameter. So now that is a lot more interesting, right? So now if you look at this, you have a setter that is being passed on, and now that we have broken the dependency on this one, right? So you say introduce parameter, right? So that is, oh no, something went wrong. I think I made a mistake here. So what we're going to do is just going to throw away this commit. We're going to say reset into this one. We're going to do a hard reset. And then we are back where we started. Now I'm trying to see what went wrong. So the second thing that I'm going to do is I'm just going to move this closer to the top of this function. So that's like a move statement. So that is not sitting well with this. I'm going to try to move it over here, right? Okay, move this over here. I'm just going to mark this as a move statement because it's also a setter. It's lazily invoked, so it's safe. Say move statement. And then let's try the one more thing. Let's just put this slightly more interesting. I'm sorry. Oh, I'm sorry. So if you look at this, there is like a name conflict here. Again a mistake in a rush. So I'm going to say where did we make this change, right? So here is where we made this change. I'm going to discard everything. It's good that I'm making so many mistakes, so you know you can how these things comes in. That helps, right? So if you look at this, this is a getter, not a setter. Sorry. So I'm just going to rename this again. This is a getter. Rename parameter, right? And then I'm just going to extract this as a variable and then call it animator setter. So that is looking good. So usually when we especially refactor code that is not under test, it's always usually like a pair programming session, like you don't do it on your own. Introduce variable, um, and then you introduce parameters, so that should change. I'm just waiting for it to not break stuff. Yeah, this one looks good. No compilation errors, nothing so far. So again, our introduce parameter. So that is good. That looks good. Now the next thing that we'll do is to make it public, because the other thing is like to notice the colors themselves. So if you don't see any purple inside this thing, that means that you've broken the dependencies of the class. But you could also use the tumbleweed tool that I showed the graph to see if you've broken all the dependencies. So now I'm just relaxing the visibility. Refactor relax visibility. Just going to push through this. And the next thing that I'm going to do is cut this one, go to some class and paste it over here. Right. So now this becomes more interesting, because now there's like bunch of stuff that comes in. There's a couple of problems that are happening here. One is basically we know like we don't have access to interpolator, and the second thing is we don't have access to Chrome, right? So in that case, what we're going to do is we're going to do things. One is like we're going to do we're going to see where this thing is, right? Okay, that's fine. I know where it is. So now I'm just going to do a git checkout again. That can go, but do a recent thing. We know that we need access to this thing, right? But then this is a private class. I'm going to make this internal so that I can have access to this interpolator. So then again, this is like a change that is not very damaging. Relax visibility. So that goes again. So the thing is like when there's a compilation error, we don't push through, we just like skip. And the second thing is we didn't have access to the home field, right? So we didn't have access to this. So we're going to say private val Chrome, and then I'm just going to say make parameter. So now that is done. So now the next step is for us to go back to the same place, and then we say, okay, we were here. What is the function that we were there? Sorry. We were at animated set or .invoke, whatever that is. Animate Chrome function, right? So this is the function. So we're just going to do this, try this out again, right? We're going back to the Chrome class, and then we'll put it here, and then we're going to just wait for compilation errors. So there are no compilation errors. So this is interesting, right? Because this is a manual move that we did, right? So we moved this method from one class to a different class, but then you can also see that there are a couple of places where this is happening, right? So now you know these compilation errors are because this class is no longer accessible from the current place, right? So what we could do is you could do like a some class. Sorry. So there's a nicer way to do this. Some class. But this, right? So now you have proof from the compiler that tells nothing is wrong, and then you can do a command B to see that the relationship still exists, right? And I'm going to make this a safe change, because one is we know we have moved this function to a new class. We still have dependencies that we have to deal with. But then you have also deleted the old function from the old class, and then the call sites have a receiver in them, right? So once you start doing this refactoring, especially when you are not in a position to write tests and leveraging the IDE and the compiler to do most of the work for you, you know, like these patterns occur commonly, right? Like when you move a function, the function gets deleted in the source class, it gets added in the distribution class, and all the call site get a receiver. So the moment you can look at this, and you could just say, yeah, this function, right? So this is one technique where we're in a position where you're not able to write tests or like do stuff, but then oftentimes we rely on the IDE feedback to do this. We're almost out of time. I am guessing we have to push through this. When you, there are like three situations. One is reducing complexity, the other one is improving structure, the other one is improving performance. So for 1 and 3, I would not refactor without tests. So test is a mandatory thing if you are especially trying to deal with 1 and 3. But with 2, which we did, so right now we're trying to edit the structure of the code, and then you have the language grammar that will prevent you from making some mistakes, right? So we are only moving things around into their respective places. So improving structure is super helpful and like on large classes and very large code bases, and it's also relatively cheap to do if you have the right information at hand. So unfortunately, we were not able to finish the entire move today, but that is how it typically looks like. But when we do this at work, we typically pair, when you're not writing tests, mark every commit, whether it's safe or unsafe. We constantly review each and every single commit before we raise a PR, and then we also manually test things because of reasons why automated testing could be expensive or not feasible, right? But they still have an option. But then if you're especially trying to reduce complexity of a function, or if you're trying to improve the performance of your code, you should definitely get it under test before you do it. But otherwise, if you have a nice IDE like IntelliJ, it is a breeze to work on these kind of problems, and it's also quite interesting. So the tool is available from the sync. You could go here. It has all instructions on how to set up and how to run. It's basically a brew install, and then you should be able to do it. Not a lot going on here, and I would also recommend this book. It's an amazing book from Adam Tomhill about legacy code work and how do you visualize data, collect data, surface the problem so that other people and other team members can understand. Because when you're working with large code bases, paying of tech debt is very hard because it's very hard to track of work or like to figure out completion or bring visibility into the problem. So this is a good read. It's his oldest book, but then I would recommend his other book. But then this is more association with CodeMart, which we use for behavioral code analysis. And there's also another tool called Clock. This is also one little tool that I really like to take a good quick look at classes. So it's also like do a brew install Clock and it gets installed. That's one way I try to do all this stuff. Don't worry, like these slides are available so you could see all of these stuff. The summary is vocabulary and relationships are the key to understanding a class, and good questions. When you ask really good questions, it helps answers to maintain a class, and then also helps build trust. And you can safely refactor classes, especially if you are building a lot of redundancies into the process and heavily relying on compiler and the IDE to make the right kind of changes for you. It's called provably safe refactoring, and you could Google about it. There are very few articles about the topic, but they're quite nice. The compiler and the Git user interface and the IDE, like they can really come in handy for you in situations where you can't really do much or it's hard to do. So that is it. I think we're out of time, and hey Mala, like we can wrap up. I had to push
First,
through. I'm very sorry.
First of all, thank you so much, Raghunath. It was a joy to see you present this session. And I know I learned so many things during the tech check and the dry run that we had earlier. And it was amazing to kind of go through all the steps that you mentioned the other day. And it was amazing. It was amazing. Thank you
Thank you,
so
Mala.
much.
Thank you.
So I will talk about this question, which you mentioned was a good question to address.
Yeah.
Yeah.
So there are a bunch of ways how we do impact analysis, right? So one of the things that we do is if you look at the R double bang thing that I add to the commit. So whenever we make those changes to this commits, right? So what we do is we try to see which function is being affected by this commit, right? And then we try to make it as part of our manual testing plan, right? So that every unsafe change that you make to your code base are targeted in very specific ways, right? So that is one way that we try to do impact analysis when we do this. And it also helps to have someone in the team who already has context about the code base, right? Otherwise, what happens is if you want to find out the right flow, then you may have to add like the log statements to figure out like, hey, am I in the right flow and am I testing this, right? And have I added log statement to the previous version versus the current version, right? So that is one kind of analysis that we do, especially with this one particular workflow. But then when you also talk about other kind of impact analysis, we also try to do, like say, for example, if you're shipping a release and then you want to compare a diff between a package, then we would take the Git history, parse it, and then look at it as a tree view, in a tree view structure, right? So that way you know like which files were affected and what quantity of those files were affected. So those are two different things for two different reasons. So the first one is like the one that I mentioned is very specific to the refactoring workflow that I talked about. The other one is more like making a release or like shipping like a larger change so that not only you but other people in the team also get visibility into it. So it's mostly writing parsers that will parse this data for you, and then like most of them are visualized using observable HQ. So it's most of it is basically parsing and visualization. Yeah, that's how it boils down to.
Makes sense. So there's another follow-up comment by the same person, and he is curious that he makes changes to the class almost every day. And I think you covered covered that when you are talking, when you mentioned that if any change is being made to the code to improve its performance, then the tests need to be placed,
Yes.
need to be in place. So, are there any quick kind of a list where a developer could refactor without having the test in place, or is it like do's and don'ts kind of a thing?
So I think if you're trying to, in object-oriented programming languages, right, basically you have data and behavior, and you're sort of like trying to put the data closer to the behavior as much as possible, right? And that is basically
Right.
depends on the proximity, right? It's basically the proximity, and what we did right now is basically trying to bring that proximity closer, right? So okay, there is this one separate concern; it can be in a different place, but all of these five different things can be closer, right? So those kind of refactorings are governed by the language structure, because the compiler will tell you like, hey, like you made a mistake, right? The IDE will tell you made a mistake, and then IDE can also make safe refactoring changes, right? So those are the only places I would use refactoring without tests, right? And the other place where you have to write a refactor without test is to break dependencies, right? You have things, but you need to break these dependencies so that you can create it under test. So that is the only case where we do it. And we do it only when and oftentimes we pair program, right? And there are very little cases where I do this on my own, right? Like, so right now I was doing it on my own, and you just like saw the amount of mistakes that I made, and I just had to throw out a lot of things, right?
Yeah.
But then the process itself is created in such a way that we sort of optimize for making less mistakes, right? Like every change gets committed, every change has a meaningful commit message. If we make a mistake, we just throw it away. If we don't refactor under compilation errors, so we make it very thing. And then if I am going to raise a PR, then I would have to do a sync code review with someone who would review this, and then we would write down the impact areas and then test it manually. So like there is a cost to this, right? But then the
Yes.
redundancies help reduce the mistake, right? So you cannot use just the tooling or just the process to get away with it. You need everything to work in tandem, right? So the process and
Right.
the redundancies is what is like sort of make preventing you from making mistake. It's not that you're smart or you've done this for many years. Like that doesn't count, right? However, times you've done
Right.
it in the past, like I've done it in the past, and like you just saw like the amount of mistakes that I just made when I was showing this demo. So that is the only place where we would not have tests, but then we are very cautious about having tests. And oftentimes tests can be hard to write. So there is one library that I would recommend, highly recommend. I don't know how it got missed out. It's called approvals.java. It's a library specifically designed to bring legacy code under test. So it helps you write like assertions in a very nice way, and also quicker way. You could even write like combination approval tests that will sort of generate parameters for you and then combine them together so that you don't have to write your own parameters, or write individual tests to create regression protection. So that is something that people should try out. Yeah.
That makes sense. And as I said, one size doesn't fit all. So there are a lot of combinations and permutations that
Yeah.
developers need to kind of take care of. So there's
Yeah.
probably one last question that I would take is by Robert, and he mentions about inheriting a large code base that uses callbacks and RX observables for async code. And they want to refactor to use coroutines due to better ergonomics and first class Android support. So he wants to know, do you have any advice how to do this
Okay.
migration?
This is a very interesting question. I'm an RX fan myself. There's like a lot of technicalities. One is like obviously you have to have tests, right? If you're dealing with RX Java, it's a stream-based thing. It has a different programming paradigm. You need to get it under test. Like there's no way you have to get it under test. And I think like the most difficult parts would be your side effects. So especially if people are doing do on next or do unsubscribe, like like side effect operators are in play, then that becomes like a lot more difficult. But then you can still use approval tests to bring it under test, right? But one guideline that I would say is if you see a long RX chain, right? The way how the chain should look after refactoring, say for example, if you're calling function A, B, and C in an RX chain, after refactoring, it would be the reverse, right? You would have C, B, and A, right? Because you're starting from
Right.
the innermost thing and then going outside, right? So that is a guiding
Right.
light for you to see if you're like doing the refactoring in the right way, right? But I would still advise don't do like refactoring without test. You should get it under test. But then an additional thing for to look out for is, hey, how does the order of the function call change as I refactor this test? Like that is something that you need to keep attention to. So when you see the same asynchronous code in coroutines, So instead of ABC, you would see CBA, right? Because the order would have been reversed because you don't have to deal with this like long chain of callbacks.
Right.
So the nested ones,
That's
especially.
good.
Yeah.
Yeah, I know.
Yeah.
And sorry, we are running out of time. There are a couple of questions, but they are more generic, right? Like using pair programming or code reviews to improve how we understand the classes. But as you mentioned, there are a whole bunch of topics that we can talk about when we talk about comprehending the code, and you specifically delve into the vocabulary of code and how code is the true vocabulary in for any developer to understand without any mismatches. So that was great. And of course, as I said, we can go in multiple directions. Again, thank you so much, Raghunath. It was an amazing session. So if Alex, can you have the last slide so that we can just say bye and we have the other credentials? Okay. So yes, my mistake. Yes. So, everyone who's watching, thank you all for asking the questions, for being patient and staying with us. I really hope you got to learn a lot of new things on how to comprehend your large Java and Kotlin classes. And these are the credentials for Raghunath. If you want to reach out to him, you can do that. And before I say bye, Raghunath, any closing comments? Because the tool that you showed for dependency, that was great. And how can anyone access that tool? I missed that. Do you already have a link to that in your slides?
Yeah. Yes, there is a link to
Okay.
that on a slide. There is also a QR code, but then I will also be sharing the slides on the link with you so that you can update the description. I can also post it on my Twitter handle so that like people can have access to all of those things that reference in the talk. Yeah.
And yes, did you mention you created that tool? That was an
Oh,
amazing, amazing tool.
thank you, Mala. Yeah, I don't think I mentioned that, but yes, that's part of my experiment. Yeah.
Thank you so much. And we already have the next. Yes, I missed this one. Do not forget to like this video and subscribe to our channel. And we already have the next IntelliJ IDEA Live session scheduled for the next month. It's on 15th of December on a Thursday, and we'll talk about test containers, mastering test containers by Oleg from Atomic Jar. And until then, bye.
Thank you, folks. Had fun today. Thank you.
Thank you.